So in dealing with the exponentials and the logarithms, we've mostly focused on dealing with base e, but we do have the flexibility of dealing with the non-base e situations. And that often involves what I call a correction factor. I had mentioned this when we were doing the derivative here of a to the x. And I said the derivative of a to the x is a to the x because it's like e to the x, which gives itself back, but it has this correction factor that you have to multiply by ln of a. And this works for positive real a's, where a is not equal to 1 because we don't want a of 1 is a special situation, and ln of 1 is going to give us a 0, and that's not what we want here. So it works other than a of 1 for positive real a's. Okay, so in the logarithm situation, it's similar in that the derivative of log base a of x, it's like ln. ln gave you 1 over x, but in this case I need to divide by the ln of a correction factor. Okay, so that's the way I remember it is when you're doing the exponential, you multiply by ln of a, and when you're doing the logarithm base a derivative, you have 1 over x, and then you're essentially dividing by ln of a because it's in the denominator. Okay, so how would this work in practice? Let's find the derivative of f of x equals 3 to the x. Okay, that's an exponential with a different base. All right, so my derivative, I would say, it's an exponential 3 to the x, so it's 3 to the x, but then it's not base e, so I need to multiply by ln of 3 as a correction factor. And that's it. All right, in this next one here in b, I have something a little more complicated. I have both a non-base e and I have a chain rule. So again, I'm going to look at this 5x as a something. So when I take the derivative, I'm saying basically I have 2 to the something. 2 to the something should give me back 2 to the something, but then I have to multiply by ln2 because it's not base e. And then I need my chain rule argument, and I need the derivative of 5x. So I get 2 to the 5x ln2, and then I still have to multiply by a 5 because that's the chain rule derivative there. And then basically I might order this a little differently. 5 ln2 times 2 to the 5x, but it's not a big deal. All right. How about the logarithms? G of x is log base 5 of x. G prime of x, then, it's a logarithm, so it's 1 over x because it's like ln of x, but it's base 5, so I need in the denominator an ln 5 as my correction factor. Okay. And again, now here, if I want to do the derivative of this, it's log base 10 of this thing. So this is going to be my something in the chain rule. Log base 10 of something should be 1 over that something, but then because it's base 10, I need ln of 10, and then because of the chain rule says, then I have to multiply by the derivative of x squared plus 1. So I get 1 over x squared plus 1 ln 10, and then I have to multiply by 2x, so I end up with 2x over x squared plus 1 ln 10. And there's my answer in that case. So again, we just have to be very methodical about how we see a chain rule, maybe within a different exponential base. Now, most of the time we are going to be using exponential bases. So e to the x and ln of x, and that'll make our life a little easier. But we do need to know what to do in these other base situations.